Hello, I am Joervie P Adante from B12, and today I will talk about my amplitude shift keying circuit. Amplitude shift keying, or ASK, is a type of amplitude modulation which represents the binary data in the form of variations in the amplitude of a signal. The result of a modulated ASK signal shows that the output signal is the analog carrier if the input digital signal is logic 1, and the modulated output is 0 if the digital input signal is logic 0. In other words, it gives a 0 value for low input while it gives the carrier value or the carrier output for high input.
Before I start discussing one by one, this is my full circuit diagram.
This is my square wave oscillator which produces my square wave signal or my binary signal of alternating logic 1 and zeros. I used my 555 timer IC to produce my digital binary signal. It has 8 pins shown above, and my number 1 pin is grounded, my number 8 pin is where my power supply is connected, and the number 3 pin is my output connected to the modulator. The output of my square wave oscillator is this, an alternating binary signal of logic 1 and 0. For my logic 1, it produces 4 volts approximately, and then for my logic 0, it produces 0 volts. It is an alternating of 4 volts and 0 volts. Next is my sine wave oscillator, which produces my high frequency carrier. My sine wave oscillator is consisting of a 555 timer, a filter, and an op-amp. Still, my 555 timer produces the square wave. However, the output pin or the pin 3 is connected to my low-pass filters and then high-pass filters, which filters different types of harmonics to produce the sine wave. Then, the sine wave from my filters goes to my inverting amplifier. I used an LM741 inverting amplifier to amplify the sine wave from the filters. The output of my amplifier is pin 6, which is connected directly to my modulator. My final output sine wave is this, which has approximately a frequency of almost 30,000 Hz. And lastly, I used a transistor as my ASK modulator. My ASK modulator transistor is 2N3904, which modulates my ASK modulated signal. My modulator accepts the signal directly from my sine wave modulator to its collector, and then the binary signal from my square wave oscillator to its base, and lastly, its collector is connected to the ground. Before it's connected to the ground, it has a parallel 1 kilo ohm resistor and 1 nanofarad capacitor. My ASK modulated signal is collected or read from my emitter. The final output of my ASK circuit is this, which produces an ASK modulated signal.
So this is my oscillator circuit with its result, a sine wave of approximately 30,000 Hz. Then, let's proceed to my digital signal circuit. It produces an alternating of binary signals of logic 1s and 0s. Then, for the last circuit of the simulation, my ASK modulating circuit, which produces my ASK modulated signal. At logic 1, it produces the carrier high frequency signal, and at logic 0, it produces 0. Then, simulating all 3 outputs, it produces this. As you can observe, the ASK modulated signal follows the pattern of the binary sequence or the binary signal of alternating 1s and 0s.